So let's read this paddle wheel one here. We have the motion of a point on the outer edge of a riverboat's paddle blade is, looks like height, and then we've got this sine function, where height is feet measured from the water line, and t is time in seconds. Identify period, midline, amplitude, max and minimum values for one cycle, starting from t equals 0. Alright, and it shows us a cycle. All the points where the graph intersect is the midline, its midline, and the coordinates for maximum minimum. So let's go ahead and draw the midline in here. And let's go ahead and figure out A, B, H, and K. So it looks like A is 8. Looks like B is pi halves. Oh, no, I did that upside down, didn't I? B is 2 over pi, right? H is 1. K is 6. Let's figure out our period. Alright, our period is going to be 2 pi times 2 over pi, so our period is 4. Let's go ahead and check that. Does it make sense if it's 4? Starting here, and negative 2, 0, so I should be add 4 to that, 0, negative 2, 4, negative 2. That works. We got our right period here. So let's see what we know about this. We've solved period. I've got it right there. Midline, so let's write it. Midline, we can see it, is y equals 6. Amplitude equals 8. We got it right here. Max, so it looks like I have a max at, if I am not incorrect, and I don't think I am, it's going to be at 2 plus 4 times the number, right? Because the period's 4, so it's going to meet that maximum, and another 4, so way out here at 6, right? So, and then I'll just say the max is 14. What else do we need? We need minimum, so I'll say minimum. Looks like we've got 0 plus 4n, and what is that, negative 2, which makes sense. If the paddle wheel is going to push a boat, it has to go underneath water. And do we miss anything? For one cycle, it's graphed. I think we got everything already. Interpret these points in context. Well, this is the point that it's underwater, right? This is the point where it's above water. I'm okay with that. So we'll say negatives are beneath water. Done. Nice and easy, right? Let's come down to this one. I did a little preemptive work on this. It didn't do the graph for us, so the hardest part is going to be doing the graph. So the K, right, is right there. It's 80. And then I drew my middle line. My A is 70, which meant up from 80 to 150, I drew another line. Right? And down from 80 to 10, I drew another line. Right? And looks like my B is 0.75, or sorry, my H is 0.75. My B is this flipped over. It's 7 over 2 pi. Right? And I think that's everything. So 7 over 2 pi. So here's how you get the period. Right? It would be 7, I'm going to do it over here, over 2 pi times 2 pi. Kind of a nice way to make any period you want, right? Just whatever period you want over 2 pi will give you the period, which gave me a period of 7. And that's all we really need. Now, I graphed it pretty much. What I did is I figured out my period was 7. So I broke that into quartiles, right? I knew that if I have, and I'm just going to go over in context. If something's 7, we want to break it into quarters. And then halfway is 3.5, right? That's 7 divided by 2. And a quarter of a way is this divided by 2, which is 1.75, right? 3/4 of the way are these two added together, which would be what? 5.25. And so those are the distances between those maximums and midline and minimum points. So here's what I did with it. All right, I started right here because this graph shifted over 1.75. So this was going to be the middle of my graph. And then I went 7 over because my period's 7, right? And I put another one. This plus 7 is 8.75. And then I just started doing what we normally do, right? So after a quartile, which would be this plus 1.75, that's 3.5, I reached the top. Again, that's just a fourth of a period that I'm doing. Add 1.75 back to this, I get 5.25 right here, and I reach the middle again. If I add 1.75 to this, another quarter, that's 7. And then, I went too low, should have been right here. 7/10. And then 8.75, which is a full period, I'm back to the midline, which is 80. And I graphed it. I'll put some little arrows there like that. So let's look at it. See what it is. I feel guilty I didn't read everything. The motion of a gondola car and a Ferris wheel at a Navy pier in Chicago can be modeled by this. All right, h is height, time is minutes. Identify the period, which we've got. Period's right here at 7. Midline, which we got. Let's write it. Midline is right here at 80. Amplitude, which we have. Amplitude is 70. All right. Max and min values. So let's do a max and min. So I've got a max at right here. It's 3.5 plus, and it's going to happen every period. So I'm going to say plus 7n because that's how long a period is, and that's 150. All right. I've got a minimum over here. Now notice I have two minimums. It's kind of easier right here to use this one. I've got 0 plus 7n, and I can actually see it. 1n plus time, so 1 times 7 is 7, and I can see both minimums here. So 0 plus 7n, and what is that min at? 10. And that's it. I'm going to pause there and let it go. Guys, I will see you next week. Make sure you do 1 to 7.